So our problem this time is looking at a miniature railway which is of length 1,000 meters, and we have a few things to play with. And this is where a question starts to lead you through to the maxima minima. It doesn't really go straight in the maxima minima, it takes you through. So it's nice in those terms because it allows you to develop these expressions. If you can't develop these expressions, then at least you're having to work with the next part. So the first one says if you've got a rectangle which is of y meters and the width is x, so there's our rectangle there, show that y can be expressed as that. Well, that's what our object looks like. So you've got the rectangle with two semicircles at either end, and you have that being x there and that being y. So the radius there would be half x. So our perimeter of this would be two lots of y, and then two lots of a half times pi times the pi times the diameter, which is x there. So the 2.5 cancels, so we just get pi x and py and 2y. We know p is equal to 1,000 because that's in the question. So the 1,000 then would equal 2y plus pi x, and then we just manipulate our algebra to get y, and there's the expression we need. So show then that the area of the track is given by that expression. So again, even if you can't get to this part, which might be hard for some people, you can do the next part, which is to find the maximum area. So that's why the questions are set up like this. That's what exam questions will look like. So we get our area. So there's our area of our rectangle, and then there's the area of our circle, which is a half pi r squared is the area of the circle. We've got half a circle on each end, but we've got two of them, so the 2.5 cancels. That would give us a quarter pi x squared times xy, and we know what xy was now because we can't just differentiate that from here because we've got x and y. Pi is a constant, so that part's not okay, but that's not. So that's why we have to substitute this expression for y, expand it out, and then again we're manipulating our algebra. I'd prefer, if I'm going to differentiate, to leave it like that, but the question said put it to that point. So then we can have to do that. But when I go to the next part, and that's to derive it, I'm actually going to derive this expression because that's easier to derive than that. It's easier to manipulate. It's easier to play with. So the derivative of a with respect to x is 500 minus pi x on 2 from what we had in the previous part. Again, to find a maximum area, we set it equal to 0. We solve it, and it's a pretty easy solution because x would be equal to 1,000 on pi. So there's our value of x. We get our second derivative, so we derive this expression. We get minus pi on 2. Well, that's always negative, so it must be a maximum. Put the 1,000 on pi into our expression for the area, and it gives us 79,577 meters squared, which if we've got the idea that 10,000 meters squared is 1 hectare, it works out to be about 8 hectares. So it says miniature railway, it's still pretty big. So this one here, we've got a diagram of a flag, and it's bicentennial flag. So this question comes from 1988, just if you're interested. So we've got two green sections of the flag and a yellow there. So that's X. We've got A, B, and Y. Now, things to note in this one: X and Y are variables. A and B are not. Okay, so just be wary that's we're not going to be able. The question asks us to play around with this first, so we get A and B, so we can eliminate them. So A plus B is equal to 188 minus X minus Y. So, well, technically I said they weren't variables. They are variables because X and Y changes, A and B would change. But we're going to do this manipulation to get rid of them. So from now, the perimeter was 376. So we got the 376, and there's 2 times the A plus Y plus B plus X. And so A plus B plus X plus Y would equal 188. So the A plus B is equal to 188 minus X minus Y. So there's that expression there. We also know the area is 6561. And so the AX and BX is 6561 because that's what's got to cover by the green region. So we get X times the A plus B, or A plus B is equal to the 6561 on X. Now, A plus B is equal to both these expressions. So we can make them equal to each other and then get y by itself. So that's how we get that expression. Again, it's about all that manipulation of algebra. And what we want to do is find the width of the yellow stripe to be a maximum. So, well, if we want to do that, we want to find the derivative of y, so with respect to x. Well, that's the expression we got. So we derive it. We get the minus 1, 6561 over x squared. Set it equal to 0. We take our 1 across. And if that's going to be equal to 1, then x squared would have to be equal to 6561. And nicely it works out as 81. We get our second derivative. We're going to test in the second derivative because the derivative that derives to 0, and that becomes 13,122 on x cubed. And when x is positive, then the negative there would make the whole thing negative, so it must be a maximum. X is 81, we sub x in and we get 26. A plus b would equal 81, so there are our dimensions. So there's the manipulation again. We're manipulating our algebra in the earlier parts of the question to get an expression to derive, set equal to 0, prove that it's a maximum or minimum, and then do whatever everything else they want, such as find the dimensions or find the area or find the volume.